Good morning, guys. Anjani Kumar here, dealing instrumentation subject for final year electrical students. Till now, we successfully completed half of the unit regarding instrumentation. What is a measuring system? So till now, what we covered means what is a measuring system? What is a definition for a measurement? What are the different types of instruments that are used to find the measurement, and absolute instrument, primary, secondary instrument, right? Portable instrument, right? All these things we discuss. What is indicating type instrument, integrating type instrument, recording type instruments? These are the things we discussed. After that, what are the static characteristics in the instrument? Each and every instrument, that it has some static characteristics and dynamic characteristics. Static means it doesn't vary with the time. So what are the static characteristics? In detail, we explain each and every static characteristics with an example. If you have any doubts, feel free to ask me about static characteristics, because those are very, very important in this first unit. The accuracy, precision, resolution, linearity, sensitivity, range, spam, right? So reproducibility, repeatability, these are the desirable static characteristics. Desirable means it's enough. Definitely we require these type of characteristics. After that, in a static characteristics, we have undesirable characteristics also. Those are hysteresis characteristics. Drift is there, right? So these are the undesirable characteristics, right? We don't require these type of instrument, these type of errors, these type of characteristics in the instrument. If you got, definitely the instrument will reach some sort of errors, right? After that, we discussed about dynamic characteristics also. Speed of response, fidelity, dynamic error, right? All these things we discussed. And after that, we started error analysis. Definitely, if you want to measure something, you will get an error is nothing but the deviation between a measured value and the true value. We can call it as an error. So you can also call it as a static error. It can be denoted by what you call a delta, right? Absolute error. This is also, we can call it as an absolute error. So what is an absolute error? Means it is a deviation, the difference between a measured value to the true value. We can call it as an error, right? This error that we can represent in a percentage also, that we can call it as a percentage error. If you remove into 100, so percentage ni remove cheste, that type of errors we can call it as a fractional errors. It can be denoted by epsilon. And all these things we discussed about. After that, if that percentage error defined by the user itself, that we can call it as a relative error. Very, very important question, right? If a percentage error defined by the manufacturer itself, then we can call it as a percentage limiting error, right? So all these things we discussed, and what are the different formulas to define a percentage limiting error. So what is the formula? Full scale reading by true value into percentage of accuracy at full scale. I already discussed in the last session also what is a percentage limiting, percentage of accuracy that can be specified from the full scale itself, or percentage accuracy that can be specified for a particular value itself, right? So those are the things that we discussed. Those are the mathematical calculations of an error. And after that, we have theoretical errors also. There are gross errors is there, systematic errors is there, random errors is there, right? Gross errors means you get human mistakes. So those type of errors we can call it as a gross error. Human mistakes means carelessness or inexperienced user. That person, he don't know what type of instrument that he has to take, right? And after that, systematic errors. There are systematic error means it is having an instrumental error, right? Observational error, environmental error. These are the systematic errors, right? Observational errors means by seeing parallax errors. So always you have to take the readings each and every instrument which is having some glass fittings, because why these fittings means the instrument won't reach, depends on a climatic condition, environmental condition. For this the instrument will be shielded like in a glass fittings. So each and every time if you have to take the reading, you have to take the position which is perpendicular to the pointer itself. So you can straight forward to see the reading. If you bend left side, you will get the readings, wrong readings. If you bend right side, you will get the wrong readings. These are observational error. So that we can call it as a parallax error also. After that, environmental error, right? Due to the humidity, temperature, electromagnetic fields across the instrument, right? Static fields, electrostatic fields. These are the things will definitely create an error. So these type of errors we can call it as an environmental error. And after that, instrumental error in a systematic. Instrumental means substandard materials, right? Not that particular actual material, substandard low quality materials. If you use this type of low quality materials used in an instrument, the instrument will read an error. So these type of errors we can call it as a instrumental error. So what are the instrumental error? So those are percentage limiting error, guaranteed accuracy error, loading effect or loading error due to the aging. Aging means ఆల్రెడీ యూజ్డ్ ఇన్స్ట్రుమెంట్ యూజ్ చేస్తూ వచ్చామనుకో, డెఫినెట్లీ కొన్ని సంవత్సరాల తర్వాత ఇట్ విల్ రీచ్ అన్ ఎర్రర్ బికాస్ దట్ లైఫ్ టైమ్ ఈజ్ ఓవర్. సో then that expiry date of that instruments are over. So you are doing the experiment with that instrument, definitely the instrument will reach an error. After that, irregular spring tensions will reach an error, right? Irregular spring tensions also will reach an error. After that, we discussed about random errors, right? We don't have any particular reasons for this type of random errors, right? Right, we don't have any particular reasons for this type of error. We just neglect these errors, right? Basically, we are engineers, we don't want to neglect those type of errors also, but we don't have any theoretical calculations for this. So we have a mathematical representation to reduce these type of random errors, right? We can reduce only these type of errors. So what is a mathematical representation means? Statistical analysis. So we discussed about the statistic analysis of a random errors also, right? There are several formulas is there. In the last session we discussed about each and every formula in detail. What is the mean value, what is the deviation value, right? What is the mean deviation, right? And after that, we discussed about what is deviation, what is the mean of deviation, what is a standard deviation, right? Variance, precision index, probable error, right? Sigma, mean of probable error, mean of standard deviation, and all these things we discussed in the last session, and we did one or two problems also, right? So with this up to error analysis, till now we successfully completed our subject. Now we move on to the concept called signals. Signals and the representation. It is related to electronics because we have electronic instruments also like CROs, right? Transducers, right? All these things we discuss in a further sessions, right? Right, today's class we are going to discuss about what is a signal and what is a representation of a signal. Right, shall I start the fresh session, fresh concept? Till now we repeated all the things that what we completed, right? Now what is a signal? Right, signal is nothing but it's a physical phenomena, it's a physical component which transfer the which can carry the information. The signal is nothing but which can carry the information, so that we can call it as a signal. Which each and every signal that it has some quantity, right? Each and every signal that it has some quantity. Each and every signal that represent it depends on a time, right? A signal is nothing but which can carry the information, right? We have a human voice, is there, so it can carry the human voice signal to another person for other distances, right? Power signal, electrical signal, so it can transfer the electrical power from one place to another. This is nothing but a signal, audio signal, video signal. In this component, these are the components which can carry the information, right? Physical components which can carry the information, right? Each and every signal that it has some quantity, right? Each and every signal that depends on a time value, right? For a particular time, how much signal will be transferred. For a particular time, how much signal will be calculated, and all these things with this, right? If the signal depends on a time, means each and every signal that it has some frequency, right? In electrical signal we have a low frequency. In electronic signal we have a high frequency components to transfer these type of signals, right? So we discussed what is a definition of a signal. So what is a signal? Signal is nothing but which can it's a physical components which can carry the information. Each and every signal which is having some quantity, right? Signals must be a time dependent, right? If the signal depends on a time, means each and every signal that it has some frequency also, right? So each and every signal which is a function of a time. So what are the examples? Power signal, voltage signal, current signal, right? Human voice. These are a representation of a signals, right? Sinusoidal signal and all this. Definitely there are number of signals is there in a system. Now what are the standard test signals? So what is the importance of a standard test signals? So you have to know, right? If you have a system, so you have to predict the performance of a system. So for this you require an input, right? So right, so for this, what type of signals that you have in your laboratory, you can easily generate these type of what are the standard test signals. You just want to study about standard test signals. You already studied in the control system itself. Standard test signals means you can easily generate these signals in your laboratory itself. For suppose if you want to estimate the performance of a fan, right, you have to apply the electrical signal. So then only how the fan will rotate, how the output will come. From that you can estimate the performance of this fan. That's why if you want to predict the performance of each and every system, you must have some sort of signals, a test signal. That means you can easily generate these type of signals in your laboratory itself, right? So what are the test signals? Those are step signal or unit step signal. Let's see, I'll explain. These are step signal or else a unit step signal, a ramp signal, unit ramp signals. I don't want to much concentrate on this topic because it is you already got these type of concept in your control system subject, right? After that, parabolic signals, unit parabolic signals, and impulse signals. So these are the standard signals, right? If you want to estimate any control system, any system performance, you just apply these type of signals to the input, you'll get the output. So with that, so for a given step input, you are getting the response like this. So this is the performance of the system, because you have these type of signals in your hand. So with this you can directly apply the signal to that system. You can predict the output, right? If you want a sine wave, it's very difficult to generate the sine wave in your laboratory, because this is we have an inverter, very complex wave, very costly wave. You don't have any frequency. The signals whose frequency should be very high, very varies, right? You don't have you just have a rectifier, you just have a frequency analyzer. All right, for all these things, the sinusoidal signals that can be generated in the laboratory is very difficult. Right, for this we have a standard test signals in order to estimate each and every component performance. You can easily analyze. So what are the standard step signals? Those are step signal, unit step signal, ramp signal, unit ramp signal, parabolic signal, unit parabolic signal, and impulse signals. Right, so we'll discuss each and every signal one by one. Right, so I don't want to go for much explanation for this. Right, you know about each and everything. Right, we'll discuss about first one. What is a step signal? What is a step signal? Step signal means the signal will be look like this one. All right, for this is a T, this is a output. All right, this is A. For a T greater than 0, for a T R of T, the output whatever it may be, R of T is equal to A. That means for a T greater than 0, my signal is a constant. Right, from see here itself, R of T, this is the step signal. You can easily generate in this in your laboratory by applying just a simple knob. So if you adjust that knob, you will get the step signal. So directly you can apply to the system, you can predict the performance of the system. Alright, so what is a step signal? Step signal means the step signal will be look like this one. If T greater than 0, you'll see T greater than 0, see T greater than or equal to 0, and that means this part, T greater than or equal to 0, you are getting constant amplitude, right? So that is A. Alright, for a T less than 0, for a T less than 0, that means this part, is there any response? There is no response, so that is called 0. So this is the mathematical equation for the step signal. Right? The step signal, it will be look like this. If T greater than 0, my step output will be a constant A. Right, this is A, constant value. Right, for a T less than 0, you don't have any response, so step output is a 0 value. So that is a step signal. If unit step means this A is replaced by 1, that means I'll explain. Unit step means this step signal is magnitude is unity. That means if you tell R of T is equal to A means 1 for T greater than or equal to 0. For T less than 0, there is no step, so that is called as 0. So this is a unit step. Alright, after that, what is a ramp signal? Ramp signal means it's a linear function. It's a goes on increasing from input to output. So how the linear relationship will be? So this is called a ramp signal. That means T output. So linearly varies, right? So for this, you will say what are the equations, right? If R of T is equal to AT, for T greater than or equal to 0, this is AT. Right, for a T less than 0, is there any equation? There is no. Is there any response? There is no response. The output should be 0. So what are the equation? This is a ramp signal. This ramp signal like this, R of T is equal to AT for T greater than or equal to 0. That means T greater than 0, my signal is AT. Y is equal to mx plus c. The same slope is y is equal to mx, right? Like this, AT. That means if T is equal to 0, what is the value? 0. If T is equal to 1, what is the value? A. If T is equal to 2, what is the value? 4. Like this, it goes on linearly increasing. This is for T greater than or equal to 0. For a T less than 0, is there any response? There is no response. That should be 0. Alright. So for a T, this is the fundamental things. Each and every person know about these things. I don't want to waste my time to express more on this. If it is a unit ramp means a can be replaced by 1. So that means r of t is equal to t for t greater than or equal to 0. R of t is equal to 0 for t less than 0. So this is called unit ramp signal. And one equation is the one important note is that you know that for a ramp, for a step signal, what is the equation? R of t is equal to a. For a ramp signal, what is the equation? At. Alright. So if you integrate the step signal, you will get At. It depends on time. Integration means it depends on integration means a particular region, right? In the time domain, right? If you integrate this step signal, you will get At. So this is called a ramp signal. Right? What is the note? Integral of step signal. Very, very important. That means integral of step signal. So we can call it as a ramp signal. Very, very important. Now definitely you'll get a question in your gate or polytechnic. That means APPSC exams, right? Yes. So integral of step signal. So we can call it as a ramp signal. So this is one important note you have to note it down. All right. After that, parabolic. You know the parabolic, how it will be. At square by 2. You already studied about how the parabolic will look like. So the parabolic things will look like this one. So this is a time, this is a output. So how it will be? At square by 2. Mx square by 2. 4ac square under. All these things you know. So what is the equation? R of t is equal to At square by 2 for t greater than or equal to 0. For a t less than 0, that means t greater than 0, greater than or equal to 0, At square by 2. For t less than 0, is there any response? There is no response. So you can easily understand R of t is equal to At square by 2 for a t greater than or equal to 0 is equal to 0 for t less than 0. Alright. R of t is equal to, for a unit parabolic means in place of a you have to put one value. So with that you can calculate the unit parabolic signal also. For a step signal, R of t is equal to a. For a ramp signal, R of t is equal to At. For a parabolic signal, R of t is equal to At square by t. Now what is the impulse signal? This is somewhat important. So impulse signal means at 0 time, at 0 place, you are having a maximum magnitude. At 0 point, at the origin, you are getting a maximum output. Is it possible? Definitely not possible. So we don't have these type of impulse signal anywhere in the system, right? In 0 time, you will get the maximum value. Is it possible? No, not possible. So you won't generate these type of impulse signal. If you know the property of inductor and capacitor, so those are the concept coming out from this phenomenon itself, right? You know about inductor doesn't allow sudden change in V is equal to L di by dt, right? Right. So inductor doesn't allow sudden change in current itself. You know, see the equation. So what is V is equal to L di by dt, right? If you first you assume that if it allows the current, సడన్గా కరెంట్ అలౌ చేసేసిందంట, అంటే 0 టైంలోనే అలౌ చేసింది. సో వాట్ ద టైం షుడ్ బి వెరీ లెస్. ఇఫ్ అ టైమ్ ఈజ్ లెస్, సో వాట్ ఈస్ మై వోల్టేజ్ షుడ్ బి వెరీ హై. దట్ మీన్స్ ఇఫ్ ఇట్ ఈస్ 0, my voltage is infinity. If infinity voltage will enter into the inductor will get damage. Alright? 0 time, in 0 time you don't have any output, you are getting maximum output, means that is an impulse signal. The same thing, if you have a capacitor doesn't allow sudden change in voltage, right? I is equal to C dV by dt. If it allows, time should be 0, the current should be infinity current will goes to the capacitor will get damaged. Or else, if you understand, you have a bucket, right? In 0 time you have a right to fill the water? Definitely not possible. If you want to fill the bucket, you just need at least minimum time. In 0 time, you don't fill the water into the bucket itself, right? In 0 time. So that's why we won't generate these type of signals in your laboratory itself, but we have to remind. So if you apply these type of impulse signal, per suppose I have a system, so I don't know how the system, I don't know, the system may be a breakdown signal, the system which is having some lot of drawbacks. If you want to analyze that system performance, you directly apply impulse signal. Definitely the system output itself, whatever the signal, if you apply input step signal to the system, you have some function, you'll get the output, right? If you apply input impulse signal, you don't have any function. Directly whatever the system, that will get in output itself, right? నాకు ఒక సిస్టమ్ ఉంది, that system is very drawbacks. You don't have some particular things in that system, but I need to estimate that system performance. So directly you apply input signal as an impulse signal. So the impulse signal into that system is equal to that signal, that system. So it is very easy in order to estimate any system performance with the help of impulse signal. If you apply impulse signal, directly you will get the result. No need to any calculations, no need to any performances, right? So for this type of impulse signal can be useful, right? Impulse signal, it can be denoted by del of t. So that is equal to infinity for t is equal to 0. That means t is equal to 0, you have an infinite magnitude, right? T is equal to 0, you are getting infinite magnitude. And t greater than 0, is there any response? 0. T less than 0, is there any response? 0. So that means at t is equal to 0, you have infinity. T not equal to 0, it should be at 0. Now we'll see the concept, right? You know about integral of step signal is a, right? Integral of step signal is a ramp signal, right? Now integral of ramp signal. So what is a ramp? What is a ramp? Ramp means AT, na? So integral AT, that is equal to AT square by 2, na? AT square by 2. So that is nothing but parabolic signal. So these two statements are very important, right? Means what are the statement? Integral of step signal is equal to ramp signal, right? Integral of ramp signal is equal to parabolic signal. So this is very important. You can define from the differentiation itself. You can integrate me, you have to eliminate. If you want to eliminate this integrate, you have to apply d by dt. So you will get d by dt. You will get d by dt here. So I'll clearly note it down here. Just understand. See. So integral of step signal is equal to ramp signal, right? Integral of ramp signal is equal to parabolic signal. So from the definitions itself, it will be clear. That means a step signal ante t. If you integrate AT, ramp signal ante AT. If you integrate AT square by 2, that is a parabolic signal. But you can express these formulas in the differentiation itself. If you eliminate this integrate, apply d by dt here. Same thing, d by dt here, d by dt here, d by dt here. You can state your statement. Differentiation of ramp signal is equal to step signal. Differentiation of parabolic signal is equal to ramp signal. So these two statements are very clear, very important. So what are the statement? Integral of step signal is equal to ramp signal. Integral of ramp signal is equal to parabolic signal. Or else differentiation of ramp signal is equal to step signal. Differentiation of parabolic signal is equal to the ramp signal. So with this These are the different types of standard signals that are present in the system. So with this standard signal, you can easily predict the system performance, right? We have a laboratory, so you can easily generate these type of waveforms in your laboratory. So with this, you can estimate each and every component performance. All right. After that, there is a Laplace transform. So this is a very important phenomenon, important note. You have to note it down, every person we discussed just now. Now we'll see what are the Laplace transform. It will be helpful. That's we don't have any that much concept on this. So step signal. So what is the step signal? You already discussed in your control system subject, right? Step signal means A. So what is unit step means 1. Ramp signals AT. Unit ramp T. AT square by 2, parabolic T square by 2. Impulse signal del of T. If you apply a Laplace transform, A means A by S. Laplace transform of A by S. Laplace transform on 1 by S. AT means 1 by S square. A by S square, 1 by S square. A by S cube, 1 by S cube for a parabolic signal. And after that, what is the impulse signal? Laplace transform of impulse signal is equal to 1. That's why you apply a impulse signal. If you want to, Laplace transform of output by input is my transfer function, right? Laplace transform of output, you don't know. Laplace transform of input, whatever the input that you are applying, if you apply impulse signal, what is my input Laplace transform? That is a 1. That is nothing but transfer function is equal to Laplace transform of output. So you can easily predict the system performance if you apply a impulse signal to the system, because you don't have any calculations when you apply impulse signals in the system itself. But it's very difficult to generate these type of impulse signal in a laboratory, because in zero time you're getting a maximum magnitude. It's very difficult. So with this, we completed the standard, we completed the definition of a signal. So signals means it can carry the information. It depends on a time. That's why each and every signal that it has some frequency itself. And what are the standard test signals? A unit step or ramp signal, unit step or step signal, ramp signal, unit ramp signal, parabolic signal, unit parabolic signal, impulse signal. And what is a modal representation, what is a waveform representation, what is the conditions that we discussed. After that, what is the important note, integral of step or ramp, or that's note also we discussed, a very important note. After that, Laplace transforms. In the next class, we discussed about parabolic signal, periodic signal, or aperiodic signal. So with this, these two things we'll discuss in the next session itself. Thank you very much. We'll meet in the next session.